Howdy, partner. Welcome to this darn rootin' tootin' podcast. I'm your sheriff, Nex, and with me is the big bad Dr. JR. And now, here's what you have been pining for. I told my wife she should embrace her mistakes. She gave me a hug.
Just wow. Okay. Anyway, welcome back to AI Innovations Unleashed, the podcast where we break down the latest trends, innovations, and real-world applications of artificial intelligence. I'm your host, Dr. JR, and today we're diving into the fundamental force behind all AI advancements: data. Artificial intelligence may get all the attention, but without high-quality data, AI is nothing but an empty shell. Today, we'll explore why data is the true backbone of AI, the skills you need to harness its power, and the essential tools for working with data effectively. And I'm thrilled to welcome back Alex Carter, a data scientist and an AI strategist who has graciously been with us for each of these episodes. Alex, welcome back to the show.
Thanks for having me back, Dr. JR.
All right, let's start with the big question. Why is data the backbone of AI? Now, we hear a lot about AI being intelligent, but here's the reality. AI doesn't think like a human. It doesn't have instincts or intuition. Instead, it learns from patterns and data, just like a student learning from textbooks, but on a much larger scale.
That's a great analogy, Dr. JR. AI isn't like a human genius that magically knows things. It's more like a student that gets smarter with experience. And that experience? It comes from data.
Exactly. Let's break it down further. When we talk about data in AI, we're usually referring to, first, numbers and statistics, so things like sales figures, temperature readings, or sensor data from smart devices. Secondly, text and words, such as emails, social media posts, customer reviews, basically anything written or spoken. The third way is through images and videos, and this is where AI uses these for facial recognition, self-driving cars, and even medical diagnosis. And finally, audio and speech. Think of Siri, Alexa, or voice assistants. They learn from thousands of hours of recorded speech.
And here's the thing. AI doesn't just need data, it needs a lot of data. Imagine trying to teach a child to recognize cats. If you only show them one picture of a cat, they might struggle to recognize different breeds, colors, or angles. But if you show them thousands of different cat pictures, they'll start to understand what makes a cat, well, a cat.
Exactly. That's why companies like Google, Amazon, and Tesla invest millions of dollars into collecting and processing massive amounts of data, because the more data AI has, the better it gets.
Now, it's not just about quantity, it's also about quality. AI needs clean, accurate, and unbiased data. Think about a GPS navigation system. If the map data is outdated or full of errors, it might lead you the wrong way. The same thing happens with AI. If the data is wrong, biased, or messy, the AI's decisions will be flawed.
And that's a huge issue. AI models have made mistakes in hiring decisions, medical diagnosis, and even legal rulings, all because the training data was flawed.
That's why data scientists spend 60 to 80% of their time just cleaning and preparing data before even training an AI model.
So, to sum it up, AI is like a chef, and data is the ingredients. If you give the chef fresh, high-quality ingredients, they'll make an amazing dish. But if the ingredients are rotten, the final result won't taste good no matter how skilled the chef is.
AI is only as good as the data we feed it. That's a perfect way to put it. Bad data equals bad AI. Good data equals powerful AI.
Alright, so now that we know data is the fuel of AI, let's talk about how we actually collect, clean, and prepare data before it goes into an AI system. Imagine you're baking a cake. You need the right ingredients: flour, eggs, sugar, etc. But what if your flour is expired or your eggs are cracked? You wouldn't want to use them, right? Well, AI works in the same way. If we feed it messy, incorrect, or outdated data, we're setting it up for failure. That's why the first step in AI development is always data collection, cleaning, and pre-processing.
Let's start with data collection. This is how we gather the raw information that AI will learn from. And data can come from all kinds of sources. Databases. Think about customer records, financial transactions, or medical records. Web scraping. AI can scan websites for information, like analyzing trends in news articles or collecting product prices. Sensors and IoT devices. Smartwatches tracking your heart rate, self-driving cars collecting road data, or weather stations measuring temperature. Surveys and forms. Companies use feedback forms, polls, and user inputs to improve AI systems. Social media and user behavior. Platforms like Netflix, Amazon, and YouTube analyze what you watch or buy to recommend content.
And that last one is huge. Every time you interact with a social media platform, you're contributing data that helps AI learn. That's why your YouTube recommendations get better over time. It's constantly collecting data about what you like to watch.
Now, here's the problem. Raw data is never perfect. Let's say you're collecting customer reviews from an e-commerce website. You might find spelling errors. This product is amazing. Missing information. Some users don't rate the product, just leave a comment. Duplicate data. The same review posted multiple times. Conflicting formats. Some reviews use emojis, some don't. Some use 5-star ratings. Others use thumbs, up, down. If we fed this raw, messy data straight into an AI system, it would get confused and make bad predictions. That's where data cleaning and pre-processing come in.
And cleaning data is kind of like tidying up your bedroom. Before you invite guests over, you want to make sure you throw away any garbage, that is, remove duplicate or irrelevant data, organize things properly into like a standardized format, for example, making all dates follow the same month, day, year structure, and then you need to fix your mistakes, and that's going to be correcting any spelling errors, fill in missing values, and removing any bias. One of the biggest issues in AI today is biased data. If an AI system is trained on data that lacks diversity, it can produce unfair results.
Exactly. For example, facial recognition AI has been known to work better on lighter skin tones because the training data wasn't diverse enough. That's a data problem, not an AI problem. This is why data scientists spend 60 to 80% of their time just cleaning and preparing data before even building AI models.
And alright, once we have this clean data, the next step is pre-processing, which basically means preparing it in a way that AI can understand. Think of AI like a kid learning a new language. If you teach a child random words without context, they'll be confused. But if you break it down into simple lessons, they'll learn much faster.
That's a great way to explain it. In AI, pre-processing includes standardizing data, making sure all numbers follow the same format, all prices in US dollars instead of mixed currencies. Encoding categorical data, turning text into numbers so AI can process it. For example, changing yes and no into ones and zeros. Normalization and scaling, adjusting values so they're on the same scale, making sure age and income are measured on similar levels.
So, what's the bottom line? Well, AI is only as good as the data we feed it. That's why data collection, cleaning, and pre-processing are some of the most important steps in AI development. Alright, now that we've covered how AI collects, cleans, and prepares data, let's talk about the different types of data AI works with. Understanding this is crucial because different AI models are designed to handle different kinds of information. You might hear terms like structured data, unstructured data, and semi-structured data. And if you're new to AI, those might sound like technical jargon. But don't worry, we're going to break it all down into simple, real-world examples.
Let's start with structured data, because this is the easiest to understand. Structured data is organized, neatly arranged information that fits into tables, spreadsheets, or databases. It's like keeping all your important papers in labeled folders in a filing cabinet. For example, bank transactions, your account balance, deposit history, and transaction dates. E-commerce orders, customer names, addresses, order numbers, and prices. Employee records, names, job titles, salaries, and start dates. Since structured data is so organized, it's easy for AI to analyze. SQL, Structured Query Language, is the tool most commonly used to manage and retrieve this kind of data from databases.
A great way to think of structured data is like an Excel spreadsheet. Everything fits into columns and rows, making it simple for AI to process.
Now, let's talk about unstructured data, which is much trickier. Unlike structured data, unstructured data doesn't fit neatly into tables or databases. It's messy, complex, and harder for AI to process without additional steps. Some common examples: text documents, emails, social media posts, news articles, images and videos, everything from Instagram photos to security camera footage, audio files, customer service call recordings, voice memos, podcasts. AI models that deal with unstructured data require more advanced techniques because they can't just look at numbers in a spreadsheet. They have to understand meaning, context, and patterns.
A good analogy is comparing structured versus unstructured data to Legos versus a pile of random objects. Structured data is like neatly stacked Lego bricks. You can easily build something with them. Unstructured data is like a messy pile of different toys, requiring a lot of sorting before you can use anything. So, how does AI make sense of unstructured data? This is where we get into some fascinating AI technologies like natural language processing, or NLP, and computer vision. Let's start with NLP. What does that mean, Alex?
Great question. Natural language processing, NLP, is how AI understands and processes human language. This includes written text, spoken words, and even slang or emojis. Every time you use Google Translate, ask Siri or Alexa a question, get autocorrect or predictive text on your phone, see spam filters blocking junk emails, you're interacting with NLP-powered AI.
And that's what's so incredible. So, NLP is what allows AI to read, understand, and respond to human language, even though computers don't actually think like we do.
Exactly. AI models use NLP to break down language into smaller parts like tokenization, splitting sentences into words, sentiment analysis, detecting emotions. Is this review positive or negative? Named entity recognition, identifying names, locations, and dates in text. And thanks to machine learning and deep learning, NLP models keep improving, so chatbots, voice assistants, and text analysis tools get smarter over time.
Now, while NLP helps AI understand text and speech, computer vision helps AI interpret images and videos. For example, with facial recognition, you can unlock your phone with Face ID now. For medical imaging, AI can detect diseases in X-rays or MRIs. And in self-driving cars, AI can identify road signs, pedestrians, and other vehicles.
Right. But just like NLP, computer vision doesn't see like humans do. It analyzes patterns in pixels and uses deep learning to recognize objects. One of the most famous AI models for this is convolutional neural networks, CNNs, which can identify patterns in images. For example, AI can be trained to recognize a dog versus a cat, a cracked windshield versus a clean one, a cancerous cell versus a healthy cell.
So, just like NLP helps AI understand text, computer vision helps AI see and make sense of visual data, which is why AI can now scan faces, detect fraud, and even create art. Okay, now we mentioned semi-structured data earlier, which falls between, of course, structured data and unstructured data.
Right. Semi-structured data has some organization, but it's not as rigid as structured data. Examples include JSON files and XML data, used in APIs and web applications. Emails, the subject line, sender, and timestamp are structured, but the email body is unstructured. NoSQL databases, like MongoDB, which allows more flexibility in how data is stored. This type of data requires special AI techniques to analyze both structured and unstructured components.
All right, so why is it important for AI developers to understand these different types of data?
Because the type of data determines what kind of AI model and tools you need to use. If you're working with structured data, you'll probably use SQL databases, data analytics tools, and regression models. If you're dealing with unstructured data, you'll need NLP, computer vision, and deep learning techniques. If your data is semi-structured, you might work with JSON, NoSQL databases, and hybrid AI models.
So, for anyone looking to build a career in AI, understanding how data is structured and which AI tools are best for each type is a critical skill. All right, so far we've covered why data is essential for AI, how it's collected and processed, and the different types of data AI works with. Now, let's get practical. What skills do you actually need to work with the data? Whether you're an aspiring AI engineer, a data analyst, or even a business leader trying to understand AI better, there are 3 fundamental skills you should focus on. First is SQL, or Structured Query Language, essential for handling and retrieving data from databases. Another skill is Python for data science, the most widely used tool for analyzing and processing large data sets. And you would need data analytics and visualization tools. This helps make sense of complex data patterns. Let's break these down and explore why they are so important in AI development.
Let's start with SQL, which stands for Structured Query Language. This is one of the most important skills for anyone working with data, whether in AI, business intelligence, or software development. SQL is a language used to communicate with databases. Think of a massive digital library. SQL is the system that helps you search, organize, and retrieve information efficiently.
That is a great analogy. Most companies store their information in databases, things like customer purchases, medical records, financial transactions, and inventory levels. Instead of manually searching through thousands or even millions of records, SQL lets you quickly filter out what's relevant and organize the data for AI analysis.
Exactly. AI models often need specific types of data to train effectively. SQL helps professionals extract relevant data without unnecessary clutter, filter and organize large data sets before AI processing, combine different data sources for a more complete picture. Without SQL, AI engineers would spend hours digging through raw data manually. SQL automates and streamlines the process.
Now, let's talk about Python, the most popular programming language for AI and data science. Python is widely used because it is easy to learn. Its straightforward structure makes it beginner-friendly. It's also highly flexible. It's used in data analysis, machine learning, automation, and even web development. And it is packed with tools. Python has an extensive collection of data analysis and AI libraries that make working with large datasets efficient.
One of the biggest reasons Python is favored in AI development is because it automates repetitive tasks. Imagine manually sorting and analyzing thousands of customer reviews. It would take weeks. But with Python, AI can analyze sentiment, identify trends, and categorize feedback in seconds. Python is also great for pattern recognition, which is crucial in AI applications like fraud detection in banking. AI can scan transactions for unusual activity. Predictive analytics in healthcare. AI can analyze patient history to predict risks. Recommendation systems. AI can suggest movies, music, or products based on past behavior.
Python acts like a data scientist toolkit, helping AI systems process vast amounts of information quickly and efficiently. Now, let's talk about something often overlooked but extremely important: data analytics and visualization. AI doesn't just process numbers. It needs to present insights in a way that makes sense to us, humans. This is where data visualization tools like Tableau, Power BI, and Google Data Studio come in.
Absolutely. Data visualization is what transforms raw numbers into meaningful insights. For example, a company might have a massive dataset of customer purchases. Instead of sifting through thousands of rows of data, they can create line charts to track sales growth over time, bar graphs to compare customer preferences, heat maps to highlight popular product categories. This helps businesses quickly identify trends, make informed decisions, and optimize strategies.
Without proper visualization, AI-generated insights can be difficult to interpret. A well-designed chart or graph can instantly reveal patterns that might be missed when looking at the numbers alone. So, how do SQL, Python, and data visualization all come together in AI development? Let's walk through a real-world example. First, a company wants to use AI to predict which customers are likely to cancel their subscription. Secondly, they would use SQL to pull relevant customer history from their database. Third, they use Python to clean the data and analyze past behavior patterns. And fourth, they use data visualization tools to present insights to their marketing team.
And just like that, they have actionable insights. They can now adjust their marketing strategy, offer discounts to at-risk customers, or improve customer engagement.
That's why understanding these core data skills is essential for AI professionals. AI isn't just about algorithms. It's about knowing how to collect, analyze, and present data effectively. Wow, we've covered a lot in this episode, from understanding why data is the backbone of AI to learning about data collection, cleaning, structured versus unstructured data, and the core skills needed to work with AI. We've explored just how crucial data skills are in the world of artificial intelligence. Before we close, let's do a quick recap of the most important takeaways from today's discussion. First, AI is only as good as the data it learns from. So if you have poor quality or biased data, it will lead to flawed AI models. Basically, good in, good out, bad in, bad out. Secondly, data collection and pre-processing are critical steps because AI engineers spend 60 to 80% of their time cleaning and preparing the data. Other thing is there are different types of data and AI handles them differently, like structured, which is spreadsheets and databases, unstructured data like text and images, and semi-structured data, which is a mix of both, found in emails, for instance. Another key AI concept helps machines see and understand information through natural language processing and computer vision, and SQL, Python, and data visualization skills that are essential for businesses and decision makers alike. And if there's one thing to take away from today's episode, it's this: AI is nothing without data. The best AI models in the world will fail if they don't have clean, accurate, and diverse data to learn from. If you're looking to build a career in AI, start with data skills. Learn how to collect, organize, analyze, and visualize data. Whether you're a beginner or a seasoned professional, mastering these skills will set you up for success in AI development, machine learning, and data science.
And we're just scratching the surface. Data science is a vast field. And as AI continues to evolve, the demand for data professionals will only grow.
That's right. In our next episode, we'll be diving into the world of machine learning fundamentals, how AI models are trained, key algorithms, and how AI makes decisions based on data. If you found today's episode valuable, subscribe, leave a review, and share it with a fellow AI enthusiast. Follow us on all the major platforms like Apple Podcast, Spotify Podcast. Follow us on Facebook, X, Instagram, Blue Sky, LinkedIn, and YouTube, all for updates. And let us know if there's a specific AI topic you would like for us to cover in a future episode.
Thanks for having me back, Dr. JR. Always great to discuss AI and data science.
Thank you, Alex. The references we talked about today can be found down in the show notes. You will also find additional resources and readings to learn further about this topic. And thank you to all of our listeners out there. Stay curious, keep learning, and remember, innovation never sleeps. See you next time on AI Innovations Unleashed.